Lighting calculators are essential tools for anyone involved in lighting design, whether for residential, commercial, or industrial applications. These calculators help determine the appropriate number and type of light fixtures needed to achieve the desired illumination levels in a space. Several online resources and downloadable options are available, catering to different needs and preferences. One prominent resource is the Mike Holt website, which offers a lighting calculator. This calculator can be a valuable starting point for understanding basic lighting calculations. Beyond the Mike Holt resource, several manufacturers provide their own lighting calculators, often tailored to their specific products. These calculators can be particularly useful when considering fixtures from a particular brand. Firstly, Dialight offers a lighting calculator, which may be geared toward industrial lighting solutions. Secondly, Cree provides a lighting calculator that can assist in designing lighting systems using their light-emitting diode, or LED, products. Thirdly, Eaton features a lighting calculator, which may be part of a broader suite of tools and support resources they offer. Fourthly, GE Lighting provides a lighting calculator likely covering a range of applications from residential to commercial. Fifthly, Legrand offers a lighting calculator, which could be integrated into their offerings for electrical and lighting solutions. Lastly, Philips Lighting also provides a calculator. When using lighting calculators, it's crucial to understand the inputs and outputs. Key inputs typically include the dimensions of the space, the desired illuminance level measured in lux or foot candles, the reflectance of surfaces, walls, ceilings, and floors, and the characteristics of the light fixtures being considered lumen output, wattage, and light distribution. Outputs usually include the number of fixtures required, their optimal spacing, and the predicted illuminance levels throughout the space. It is also important to consider the maintenance factor, which accounts for the reduction in light output over time due to dirt accumulation and lamp depreciation. The maintenance factor is typically a value between 0 and 1, with low values indicating a greater anticipated reduction in light output. Lighting calculations often involve complex formulas and considerations, so it's helpful to have a basic understanding of lighting principles. Luminance is the amount of light falling on a surface, while luminance is the amount of light reflected from a surface. Luminous intensity is the amount of light emitted by a light source in a particular direction, measured in candelas. The coefficient of utilization, or Q, represents the fraction of light emitted by the fixtures that actually reaches the work plane. The Cu depends on the room dimensions, the reflectance of surfaces, and the type of fixture. When selecting a lighting calculator, consider the following factors. Firstly, ease of use. The calculator should be intuitive and easy to navigate. Secondly, features. The calculator should offer the features you need for your specific application. Thirdly, accuracy. The calculator should provide accurate results based on reliable data. Fourthly, vendor support. The vendor should offer support if you have questions or need assistance. In addition to online and downloadable calculators, there are also software programs specifically designed for lighting design. These programs typically offer more advanced features and capabilities such as three-dimensional modeling, daylight analysis, and energy simulation. Some popular lighting design software programs include AGA32, Dialux, and Relux. These programs can be particularly useful for complex lighting projects where detailed analysis is required. Regardless of the tool you choose, it's important to verify the results and consider other factors that may affect the lighting design, such as the color rendering index, or CRI, of the light sources, the glare potential, and the aesthetic appearance of the fixtures. The CRI is a measure of how accurately a light source renders colors compared to a reference source, such as daylight. Glare can cause discomfort and reduce visibility, so it's important to minimize glare by using appropriate fixtures and shielding. The aesthetic appearance of the fixtures should also be considered to ensure that they complement the overall design of the space. Understanding lighting terminology is also essential for effective lighting design. Lumens measure the total amount of light emitted by a light source. Foot candles measure the illuminance, or amount of light, on the surface, with 1 foot candle equaling 1 lumen per square foot. Lux is the metric unit of illuminance, with 1 lux equaling 1 lumen per square meter. Wattage measures the amount of power consumed by a light source. Efficacy measures the efficiency of a light source expressed as lumens per watt. Color temperature measures the color appearance of a light source expressed in Kelvin. Lower Kelvin temperatures e.g. 2700 Kelvin produce warm, yellowish light, while higher Kelvin temperatures e.g. 5000 Kelvin produce cool, bluish light. When designing lighting for a specific space, it's important to consider the activities that will be performed in that space. For example, a task-oriented space, such as an office or workshop, will require higher illuminance levels than a more relaxed space, such as a living room or bedroom. The age of the occupant should also be considered, as older individuals typically require higher illuminance levels to see comfortably. In addition to general lighting, task lighting and accent lighting should also be considered. Task lighting provides focused illumination for specific tasks, such as reading or cooking. Accent lighting highlights particular objects or features in a space, such as artwork or architectural details. The placement of light fixtures is also critical to achieving the desired lighting effect. Fixtures should be positioned to minimize glare and shadows and to provide uniform illumination across the space. Consider the use of dimmers to allow occupants to adjust the light levels to their preference. Dimmers can also help save energy by reducing the amount of light used when it's not needed. Control systems can also be used to automatically adjust light levels based on occupancy, daylight availability, and time of day. These systems can significantly reduce energy consumption and improve the overall lighting quality. When selecting light sources, consider the energy efficiency, lifespan, and color rendering properties. LED are generally the most energy efficient option, followed by compact fluorescent lamps, or CFLs, and then incandescent lamps. LED also have a much longer lifespan than other types of lamps, which can reduce maintenance costs. In conclusion, lighting calculators are valuable tools for lighting design, but they should be used in conjunction with a thorough understanding of lighting principles and best practices. By considering the factors discussed above, you can create lighting systems that are both functional and aesthetically pleasing. Remember to always consult with a qualified lighting professional for complex lighting projects. They can provide expert advice and ensure that the lighting system meets all applicable codes and standards. Lighting design is a critical aspect of creating a comfortable and productive environment, so it's worth investing the time and effort to get it right. The appropriate use of lighting can enhance the appearance of a space, improve visual performance, and promote well-being. When using any lighting calculator, make sure to input accurate data for the space dimensions, surface reflectances, and fixture characteristics. Pay attention to the units of measurement and ensure that they are consistent throughout the calculation. For example, if the space dimensions are in feet, make sure that the fixture spacing is also in feet. Also, double-check the results to ensure that they make sense and are consistent with your expectations. If you have any doubts, consult with a qualified lighting professional. They can review your calculations and provide expert guidance. Also, be aware that lighting codes and standards may vary depending on the location and the type of building. Make sure that the lighting system complies with all applicable codes and standards. This may involve consulting with a local building official or a lighting code expert. Lighting design is a complex field with many variables to consider. By using the tools and resources available and consulting with qualified professionals, you can create lighting systems that meet the needs of your space and its occupants. In addition, consider the environmental impact of your lighting choices. Choose energy-efficient light sources and controls to minimize energy consumption and reduce your carbon footprint. Also, dispose of lamps properly to prevent the release of harmful substances into the environment. Many lighting manufacturers offer recycling programs for used lamps. By making informed decisions about lighting design, you can create a sustainable and environmentally responsible environment. Remember to balance energy efficiency with lighting quality and visual comfort. The goal is to create a lighting system that meets the needs of the occupants while minimizing energy consumption and environmental impact. Continuous advancements in lighting technology are leading to more energy efficient and higher performing lighting solutions. Stay informed about the latest developments in lighting and consider incorporating them into your designs. With careful planning and attention to detail, you can create lighting systems that are both functional and aesthetically pleasing while also being energy efficient and environmentally responsible. Lighting is more than just providing illumination. It's about creating an atmosphere, enhancing the architecture, and improving the quality of life for the occupants. By considering all of these factors, you can create lighting systems that are truly exceptional. And, lastly, remember to regularly maintain the lighting system to ensure that it continues to perform optimally. Replace lamps as needed and clean fixtures to maintain their light output. A well-maintained lighting system will last longer and provide better lighting quality over time. With proper care and attention, your lighting system will provide years of reliable service and enhance the beauty and functionality of your space. Lighting is an integral part of any building or space, and it plays a vital role in creating a comfortable, safe, and productive environment. By understanding the principles of lighting design and using the tools and resources available, you can create lighting systems that meet the needs of your space and its occupants, while also being energy efficient and environmentally responsible.